Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be discussing about in detail descriptive stats. By the way, this upcoming portion of the video is the recording of my paid course, which I have newly launched with respect to statistics for data science. And this video is just to give you a glimpse of how the course structure looks like, how the complete classes are going on. And if still anybody is interested, we just have finished only three live sessions. Still, there are many live sessions which are pending. So if you are someone who is, after checking this kind of a demo class, is interested to enroll in the course, please go check this out. On 5th of September, on the occasion of Teachers' Day, I have opened one coupon code of Teach 50 for 50% off on all the courses. That coupon code is still applicable. I have, extended for one more day. So if you can, have that idea ki this course is really important for me after watching this video. So you can just apply that 50% off coupon code and enjoy the classes, upcoming classes in the live mode with me directly. One-to-one interaction will be there. And if you have any doubts in terms of curriculum, what things we are covering up, you can again refer the landing page of that course. Everything will be available. For sure, whatever portion is required to understand any data science project, I'm covering up each and every portion in a lot more detail. Also, you can take the reviews, check the testimonials of my website of how the people who have previously enrolled in my previous courses talks about the courses and everything. Uh, I think this is what maximum I can do from my side to give you a 50% off. So please make sure if you are someone who is interested, go check this out before it's too late. And also try to watch this session at the very end. Anyhow, if you are willing to join or not, this specific video will be really helpful for everyone to get the idea of how descriptive stats works. So here we are talking about what is the meaning of measures of central tendency, what is the meaning of measures of dispersion. With a numerical example, with the practical implementation, everything we are covering up in a lot more detail. And this video requires a lot of patience as well because my sessions are usually too long. But again, it's very interactive. If you will try to take a proper documentation for the same, you will find it really helpful in your further interviews and doing the projects as well. So without wasting any time, let's get started. And please make sure you will hit like button. You will share this content with everyone. And please, please, please do subscribe to this channel. Many people are not subscribing to it. It's really bad. It's really disheartening. So please, please, a humble request from my side. I'm doing my level best in order to reach to wider audience. But you know, right? Without your support, it's not feasible. So please make sure you will do your bit. And with this, let's get started. Yes,
Ma'am, we
what
have
things we have
covered
covered up? Mhm.
population and sample.
Okay.
Again, we have seen the need for the statistics. Then we have seen statistical modeling. We have seen that what we are going to cover in the upcoming session. We were doing the descriptive stats part. I guess we have also seen that we are going to do that. Uh,
Correct.
Apart from
Mm-hmm.
that, we have seen the Python libraries that can be used for stats, SciPy, scikit-learn stats model. We have
Mm-hmm.
seen the types of data, semi-structured data, unstructured data, uh, and what are the
Mm-hmm.
examples, for example, CSV, JSON, and all that stuff.
Mm-hmm.
Uh, After that, I guess we have seen qualitative versus quantitative data.
Correct.
We have two types of state data.
Correct.
In qualitative data, we have nominal data and ordinal data.
Mm-hmm.
And then we have seen the difference between, I guess, discrete versus continuous.
Mm-hmm. Correct.
We have seen the examples also about the same that we are using.
Mm-hmm. ठीक है.
Real world example, finance, healthcare, sports,
Yes. Correct.
IT
Any other
scenario.
thing?
Mean median?
Anyone?
No, no.
I think yes, this is what we have covered up. Majorly, what Mayank has said. We have talked about population, sample, difference between these two. We have talked about what is statistics, what is the motivation of using that, what are the different use cases where stats is being used very widely. We have talked about the types of data that we have, followed by the examples for the same. And if you remember, I have talked about the types of statistics as well, where we have discussed that majorly speaking, we have two different types of statistics. One is descriptive and another one is inferential. So, today in this specific topic, we will deep dive into what we called as the very first portion, which is called as descriptive statistics or descriptive stats. ठीक है? Descriptive statistics. Now, in the last class itself, I told you that whenever we are talking about descriptive stats, the simple meaning is that what we want is we want the description of the data set. Description means you can say summarization, right? Summarization of the given data. And there can be multiple ways to summarize any data. And again, this is specifically being used for data analysis per se in multiple domains, in multiple fields, right? For example, if let's say I will provide you a data and I want to check with respect to that data, what is the mean of that, median of that, mode of that, how much is the variance, standard deviation, and so on. So basically, we will be easily able to evaluate that specific part if we have an idea that how basically the mathematical things looks like. So with this motivation, let's try to go and understand with respect to the very first portion in the descriptive stats, and that is about the measure of central tendency, which I was talking about. Measure of central tendency. So, as I told you, we have three things in this measurable quantity part. One is mean, another one is median, and the last one is mode, right? So, mean is nothing but is the way to evaluate the average only. Median is nothing but is the middle value. In layman term, if I have to communicate to you, what is the middle value in a given data? And mode is the highest frequency. Mode is the highest frequency. So, usually, if I'll talk about, we have discussed in our last class the types of data, and I have talked about something called as categorical data as well in the last discussion, right? Where we have categories available. So, always remember when you have a categorical data, for example, class A, class B, class C, and you have to just determine that which is having a highest appearing classes, right? That is something where you can go with the mode. But these two measures, when I'm talking about mean and median, these two measures are specifically useful when we will be having a numeric data. Okay? When we will be having a numeric data. So what I will do over here is, I think it's a better idea that we will go with some example and we'll try to understand that how basically we will be able to evaluate the mean, median, and mode, and then maybe we will see the features of that. So today, first of all, we will do the numerical calculations. After that, we will do the practical implementation, that how while writing the code part in statistics we will be able to evaluate all of these things. So that is how the flow will go. So for that, let me just fetch any numerical example. I'm looking into it, just give me a moment. So let's wait for a while. I'm writing few set of numbers over here, and then we will try to see how basically the evaluation is being done. For example, let's say I will be having a data points, which is in the form of a list, let's say LST I have, and data points looks like 4, 8, 6, 5, 3, 8, 9, 8, 2, right? If I'll ask you that how basically you will be able to evaluate the mean for the same. So what will be your answer? So mean is nothing but you will have to do the addition of all of these terms available divided by how many number of items you have. Data items 1, 2, 3, 4, 5, 6, 7, 8, 9. So the size of our list is 9, right? So when I'm saying mean, it is nothing but average. People sometimes gets confused between mean and average term, but both are demonstrating the same thing. So you will say 4 plus 8 plus 6 plus 5 plus 3 plus 8 plus 9 plus 8 plus 2 divided by 9. So whatever be the calculation, anyone who can give me an answer, whatever
It's
calculation we will be able to do, that will be the final result. Anyhow, can anyone give me the result? What is the addition of these
53.
numbers looks like?
53.
53. So 53 divided
Yes.
by 9. So you will be able to get approximately the answer as 5.89, right? So this is how basically we will be able to evaluate the mean of any given data item. At the same point of time, if I'll ask you what is the median of these numbers, how will you evaluate? Given these data items, if I'll ask you how can you evaluate the median of a given data items, so what is the process over that part?
So it depends upon the if it is odd or even.
It
Here
depends
we
on
have
the
odd and even
Okay,
basically number.
it depends on whether we will be having number of data items as even or odd. Okay, here for now we can see that it is an odd item. But the question is what is the process to evaluate the median? So directly you will be able to fetch the middle value. Is that like that something will
So
happen?
we have to sort basically
That is
these
something which is
elements.
very important. I have seen so many people, whenever I'm talking about this median term, I don't know, they have a misconception that directly they usually try to fetch up the data points. But that is not how we can evaluate the median. Always remember the first step is to sort your data or is to arrange your data in an ascending order. So when I'm saying arrange your data, you will start arranging with a 2, followed by I think we have 3, followed by I think we will be having 4, then we will be having 6, no, we will be having 5, right? After that we will be having 6. After that I think we have 8 3 number of times if I'm not wrong, and at the end we have 9. Is it correct or some numbers I have missed? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's correct, right? So if let's say, because here we will be having 9 numbers, so what I will do is I will directly see, I will skip the initial 4 elements and the last 4 elements will take the number, which is the middle one, and will return the answer as 6. This is the way to evaluate the median when we will be having a odd number of elements. But if I will say that I have even number of elements, for example, if let's say given this data points, I will add one more data point. Maybe I will add 6 also one more time. If let's say n is not 9, n is 10, where I'm changing my data bit, I'm saying 2, 3, 4, 5, 6 is appearing 2 times, 8 is appearing 3 times, followed by 9. Now, if I'll ask you what is the median of this specific number, so what will you do in that case? Simple idea could be, because now you cannot take a single element. You have to skip the initial 4, you have to skip the last 4. And what you will do? You will take the middle two elements. You will take the middle two elements and will try to do the average of this. So what will happen is you will say 6 plus 6 divided by 2. So definitely it will be 6 only. Although the results are same, but I hope you get my point that whenever we will be having an even number of data points, we need to take the average of middle two entries that we have. Whereas when we will be having an odd number of data points, because here the value of n is 9, which is an odd entry. So in that specific scenario, in that specific case, we will directly fetch the middle value. That is how basically we will be able to evaluate the median, and when the value of n is odd or when the value of n is even. So is that fine for everyone? Any doubts till so
So
far?
even
Anyone?
if the numbers are same or different, it will not make any formula will be same, isn't it?
What you are saying? Sorry.
I mean, in case of even as we are taking the middle two, so same numbers or different, it has nothing to do with that, isn't it?
No, no, it does. We don't care if we have different number also. Let's say here we will be having 6 comma 7. Let's assume. So in that case, we will take the average of 6 plus 7 by 2, and whatever be the answer you will be getting, that will be your answer, right? It will be 13/2 followed by 6.5. Is it fine? Everyone is comfortable till so far? Shall we proceed ahead to the next specific measure of central tendency?
Yes.
Perfect. The last one is what we have is mode. So let's try to do a brief recap of how basically we can evaluate the mode part. So when we're talking about mode, anyone who can let me know with respect to the original data that we have, which is 4, 8, 6, 5, 3, 8, 9, 8, 2. If I'll ask you what is the mode for this?
A.
8. So basically, as I told you, frequently in real time data, it is specifically useful in categorical data, but it's not that you cannot use it in your numeric data. For example, in this case, you have to just check what is the highest frequent element that we have, and that is 8. So directly you can say that the mode value is 8. But usually in practical scenarios, I would say when you will be working with the data set, uh, in practical real time use cases, you will be able to observe that it is specifically being used at the time of when we are dealing with the categorical data. By the way, these measures of central tendency is something which is a very interesting topic in a EDA portion for those people who are already aware about machine learning. Whenever we are doing a process of data imputation, so that this specific knowledge is required. This is one of the way. It's not that we just have this specific way only, but this is one of the way where if let's say you are having a missing value available in any of the given data, so you will try to see that whether you can do the imputation via mean, median, or mode, depending upon different situations, depending upon what kind of data you are dealing with, depending upon whether your data contains outliers or not. I'll talk about that term also within a few minutes. But anyhow, for now, I have just showcased you how the evaluation is being done. So is it fine for everyone? I think to jump towards one interview question, which is very widely asked, and uh, definitely anyone can ask from you as well. So now we have some concept of outliers. I'm not sure how many of you are aware, but let me give you a brief idea about this term as outliers. So outliers, whenever you are analyzing your data, these are the, you can say, exceptional values. Exceptional values, which are the, you can say, extreme ends, extreme values available in your data set. For example, if let's say I'm saying to you that, I will be having a survey, I'm doing one survey with respect to the salaries of people who are having a position of data analytics, working as a fresher, how much is usually the average package which they are getting. And let's say few people are saying to me that, Priya, we are having an average package of 8 LPA. Few people are saying that we have 15 LPA. Few people are saying, let's say we will be having 12 LPA. I'm talking about freshers, okay? Few people are saying that, Priya, I will be having 10 LPA. And then there is a guy who is saying that, Priya, I have a package of 1 CR. Or let's say there is a guy who is saying that, Priya, I have a package of uh, 1 LPA. So, both the cases, whether it is this kind of experiment or this kind of experiment, they both are a part of an outliers. Always remember. So, any of the experiments, whether it is a low level or high level, both are the outliers available in your data. And whenever these kind of outliers are available, you know, at that point of time, you must have heard this statement. We usually say median is more robust to outliers. So, what is the meaning of that? The simple meaning is that if, let's say, in an interview also, or in your practical project implementation also, if you ever face that in your data, in your column which you're working with, you are having an outliers available, and you are doing a task of data imputation where you want to impute with the either mean or median. You have a choice, the missing values you want to do the imputation. So always and always go with the median. That's what I want to say in a layman term. Why? Because if you will try to evaluate the mean of this specific data points, definitely you will try to take the middle two values and will try to take the average of that, which is 15 plus 12 divided by 2. So you will be able to get the answer as 27 divided by 2, which is 13.5 lpa. But as soon as you will go with the approach of, let's say, mean, so you will try to see the 1 lpa plus, you will try to add 8 plus 15, right? 1 plus 8 plus 15 plus, then you will be having 12 lpa, you will be having 10 lpa, then you will be having 1 cr. So it's like you can say 100 lpa, right? Divided by 1, 2, 3, 4, 5, 6. So you will divide by 6. So you will be able to see. Anyone who can tell me what is the answer we will be able to get approximately?
62.6.
62.6.
6.
So this is the answer we are getting. So you will be able to see practically, right, how this specific term is impacted. Now you can tell me that what is the actual answer? What is the answer with respect to which we can rely upon? Can I say that this is the actual answer? No one is getting an average salary in India
I guess
as
I
a
have
starting
done
fresher
one mistake.
62.6. So always
It
remember,
is
whenever you are having an outlier available in your data, imputation will always be done via median. This is one of the very widely asked question as per the interviews as well. They can ask you which specific measure is more robust to outliers and why. So you should demonstrate this kind of explanation to them, and the answer will be median, not the mean. Always remember that median will always give you the bad result, because this is a measure which will be impacted a lot, a lot by the outliers. Always remember this thing. So with respect to this specific topic, this is one of the important part, or a key takeaway which I think you should document it, that in your future part, whether you're giving an interviews or whether you are working in any of the project, you will not do this mistake. Anyhow, this specific knowledge of mean, median, and mode we will use in the upcoming part of discussion today. So I hope that till so far, whatever things we have talked about is clear to everyone. If yes, can everyone give me the confirmation in the chat window so that I can move ahead?
it was mistake. It would be 24.3.
ठीक है, whatever with the calculation you guys are getting, I'm not sure. Even I'm not doing it. So you can recheck at your end. I'll share the notes with everyone. Please don't deep dive into the calculation part. This mathematical numbers can be fluctuating. But what point I want to convey, I hope that is pretty much clear to everyone, right? So now let's move ahead to the next interesting topic. So here we have talked about the very first thing, which is measure of central tendency as a part of a descriptive stats. Another interesting measure that we have is the measure of dispersion. So shall I move ahead to the next important aspect, which is measure of dispersion. Now, whenever we are talking about dispersion, dispersion meaning is spread of a given data. And when we're talking about spread, usually in a layman term, we say that we are trying to evaluate the spread with respect to the mean part. Mean is the average. Just now we have discussed, right? So basically, this kind of a distribution, which is a bell-shaped curve, is called as a normal distribution, by the way, for those people who don't have any idea, right? I'll talk about in detail in the upcoming sessions with respect to this distribution. Very, very important in the world of data science, statistics. But anyhow, if you will be able to observe with respect to this specific uh, part, this is the mean, which is the middle portion, which you can see in my diagram, right? So when I'm saying measure of dispersion, it means that with respect to this mean value, with respect to this middle value, how much your data is spread, how much your data is spread. And to check that specific part, we have multiple measures. Now, the very first measure that we have is something which we call as range. Is something which we call as range. Now, tell me, what is the meaning of range?
Maximum value minus minimum value.
So always remember, in a given data, if let's say you have been given some data set and someone is trying to tell you that, can you give us the answer? What is the range of that? So you need to just evaluate what is the difference between the maximum and the minimum value. So what you will do, you will just try to get that what is the maxima minus what is the minimum. For example, again, let me try to fetch some interesting question to get the better idea for the same. For example, let's say, imagine that we have a test score of the students. Okay? And I'm copying that scores. Let me give me some time. Okay? So this is the scores that I have. This is 100 and this is 56. This is comma separated. So we have these kind of scores available where you can see, is this data is repeated? I think yes. Let me go back. Hmm. Okay. Let's say this is the scores that we have for a given student. The score is 56, 64, 75, 80, 83, 90, 92, 95, 98, 100. So these are the scores of the candidates that we have. Now, if I'll ask you, in this specific data, which is the score of a students out of 100, what is the range of that? So simply what you have to do is you need to check what is the minimum score. What is the minimum score? And if you will just check it out, the minimum score would be, in this specific case, the minimum score would be
56.
56. Very good. What is the maximum score? What is the maximum score?
100.
Maximum score would be 100. Can I say, everyone? So if I'll ask you what is the range, that is something which you will be able to determine as 100 minus 56. So you will say that it will be equals to 64. I think this is the 44,
44.
sorry. 44 is the answer which we will be able to get with respect to this specific range part. Now, what this 44 is indicating, in a layman term, if you have to interpret this result, what will be the answer you will say? Like, if you have
That's the
to
range.
explain this to in a layman term, like, what is the interpretation? Okay, we have understood the formula. How can we evaluate that? But what is the interpretation of this? Yes. If I will have, I'll have to explain to someone what this 44 value is indicating, what you will say.
How far are the data points are spread?
Very good. It's correct, right? So basically, can I say that this specific measure is just giving me a quick sense of variability, quick sense of variability in the given data set? Can I say, everyone? Because I I I can definitely take a judgment that how much are the scores varying. What is the value of minimum score? What is the value of maximum score? So 44 is a number. Okay, that is the variation that student scores does have in my given data set. Now, this specific measure, if I'll see, this is maximum minus minimum. The problem in this specific measure, you will not observe or see in practical real time demonstrations in your projects also, that people are going for range. Why is that so? Because this specific measure is more sensitive to outliers. Just like the way I told you, mean is more sensitive to outliers, this range specific measure is also very sensitive to outliers. Why I'm saying so? Because let's say, I told you, right, outlier is nothing but the extreme ends. And if let's say those extreme ends are not correct, they are the exceptional values, they are the outliers. So in that case, automatically I will be able to get a very huge variability. which is not a correct way to interpret over this specific aspect. So that is why you will be able to observe that in practical real time use cases, it's very, very lower chances, I would say, where people are directly using the range parameter. That's why many people are not even aware what is range. Is it fine? Does it make sense to everyone?
So
What is the
if
issue with
I
respect to this parameter? Yes, any doubts?
can you please simplify this variability? Actually, I'm hearing it for the first time.
Variability means variation. How much is the variation you have in minimum and maximum value? So interpretation क्या बोल रहा है कि how much range is specifically measure is talking about that how much your minimum and maximum values are varied with each other. What is the difference between these two? That is something which we will be able to get with the help of this range parameter. The problem is that they are sensitive to outliers, because let's say we are talking about extreme ends, and if let's say we will be having very huge values or very small values, just like the example I have given you, in one LPA is also wrong, one CR is also wrong, both of them are outliers. So in that specific case, the result that we are getting as a part of a range parameter will completely be wrong, because outliers are not giving us a correct inference. So that is why I'm saying practically in real time use cases, we are not using it. Variance is different thing. Variability, which I am saying, is different thing. Don't get confused. वेरिएंस के बारे में भी हमने कोई बात ही नहीं करी है. I have not talked about variance for now in this session. I'm talking about variability. It's an English word which indicates the variation between the two values. That is something which I'm talking about. So it basically gives a quick sense of variability in a given data. Means how much is the variation of extreme two ends we have in a given data that is given by the range. Variance is nothing correlated over this specific point.
So in that example, 44 variability is that is you're showing now.
Yes, 44 is the, it indicates that 44 is the variation between a minimum and maximum score that we have, right? That's the variability. Make sense? Shall we move to the next important point? Perfect. Next important measure, because now we have seen that there is an issue with respect to this parameter, and that is where the next important parameter comes into picture, which we called as IQR. And you will observe that again in practical real time use cases, many people are using this IQR. Many people are going for this specific use case, right? Uh, so when we're talking about this IQR is nothing but interquartile range. So when we're talking about this, the way to evaluate this, that we are trying to find a difference between the value of Q3 minus Q1. Q3 minus Q1. Now, what is this Q3? Q3 is called as 75 percentile, and Q1 is called as 25 percentile. And there is something which we have in statistical term called as Q2, which is the indication of 50 percentile. 50 percentile. So we have Q1, we have Q3, we have Q2 available with us. Now, how can we evaluate the difference between Q3 and Q1, and how is it beneficial? For that, again, let's take some example. Uh, so maybe what I'll do, I'll take the same data set, which I have just now copied. And let's say we just now have seen what is the range of this specific data point, right? Now I will check what is the IQR of this specific data point. So now tell me, how will you evaluate the value of Q2? Range gives a quick sense of the spread in the data, but how do I interpret a range of 44 in your example? Range gives a quick sense of not spread, variability of a given data. Variability meaning that how much is the variation of the extreme ends in a given data, of the extreme ends in a given data. That is the meaning of variability over here. Don't get confused this word with the variance that we will be discussing in future part. Variability means the variation of the extreme ends in a given data. So what this 44 is indicating, 44 is indicating the variation between the maximum and minimum score. That is how you can interpret in a layman term, right? It is giving us the answer that okay, it means that we have a 44 difference as the test score difference between the people which are available in my class. That is the main idea behind the range part. Is it fine? What if both min and max both are outliers? That is what I have said. That is why we are not using this specific measure practically. This is not a very useful measure, not very useful way measure in a real time projects. That is the main reason. So that is where it is lagging, because just now the question that you have asked is the answer of your problem, that it is sensitive to outliers. So that is the main reason that we are jumping towards IQR. So IQR is resolving that issue which range usually have. If let's say you don't have an outlier, the value of min and max is correct, then we don't have any issue. It's a very good measure, it's very easy to evaluate, even the computation wise also it's not heavier task. But the problem is that only which you have just now asked, ki, Priya, what if we both have min and max as the outliers? So that is where we are jumping towards IQR topic. Now it makes sense to everyone. Shall we move ahead to the next topic? Everyone is comfortable? Chale aage? Okay, perfect. Now, in this specific case, what I was asking is the value of Q2, because we have seen IQR evaluation. By the way, full form of IQR is inter quartile range. Inter quartile range. So now, in this specific use case, if I'll ask from you, what is the value of Q2? How will you evaluate? By the way, here if you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Number of data points that we have is 10. 1, 0, 10. Now, if I'll ask you, what is the value of Q2? So how will you evaluate that? Yes. So whenever we are talking about Q2, which is we are talking about 50 percentile, this is nothing but median. Always remember. So few minutes back we have seen that how can we evaluate the median for a even entity, for a even number. So can you guys give me the answer? What is the value of Q2 as per your indication in this specific case? Can you guys write in the chat window what is the value of Q2? So what we can do is, because we have 10 data points, we can try to skip 4 from here, 4 from here, right? And because we are dealing with the even number, so we will take the average of 83 plus 90 divided by 2. So tell me what is the answer we are getting over this. Tell me what is the answer we are getting over this. So Prabhutva is saying it is 86.5. Just give me a confirmation. Is that correct? Is this correct? Yes. Now, once we will be able to evaluate the value of Q2, we have to focus on the value of Q1 and Q3. Now, when we are talking about Q1, we will focus on the extreme left sides. When we are talking about Q3, we will focus on the right side. So what you supposed to do? How can we evaluate the value of Q1, let's say Q1. So anyone who can let me know, how will you evaluate that? Huh, 25th percentile, but how will you evaluate that? So what you will do, you have 10 data points, right? So you will take 1, 2, 3, 4, 5 over here, and you will take 5 over here. Split your data into 5 components. Now, in this specific case, when you split your data into 5 components, take the middle value. When I'm saying 25 percentile, take the middle value from here. 25 percentile, take the middle value from here. And when I'm saying 75 percentile, take the middle value from the extreme right hand. So now tell me, what is the value of Q1? What is the value of Q3? Because now, because it is having a odd value, this is also the value of NS5. This is also at the value of NS5. So now you can directly get the answer. So tell me what is the answer we will be able to get over here. Tell me. Very good. So can I say the value of Q1 is 75? See this area where we will be having value 56, 64, 75, 80 and 83. So leave the two upfront and backward. We will be having middle value as 75, right? Same thing you have to do over the value calculation with the Q3. So we will be having 9090, 92, 95, 98 and 100. So what we will do over here, we will try to leave the initial two values and the last two values. The middle value is 95. So this is how basically you will be able to evaluate the value of Q1 and Q3. Again, I am explaining. First of all, 50 percentile is the middle value, which is what we call as median. Simple maths, if you will try to use, when I'm saying 25 percentile, it means that you have to split your data now towards the left and the right subset. And in the left subset, take the middle value, because that is where you have this 50% data over here, 50% data over here. So when we're saying 25 percentile means you have to take the middle value from that 50 percentile data. That is what we are calling it as 75 in this case. Similarly, if you will take the extreme end, right side, 75 percentile I'm saying, right? 50 percentile is middle one. Extreme end of that, middle value is 95, which is the 75 percentile. So that is how basically we can evaluate. Yes, 10 represents total number of entities, data items that we have. Okay. So this is how basically we can evaluate the 25 percentile and 75 percentile in a given data. Ask me the doubts if you have with respect to this part. Otherwise, we can move ahead with respect to the solving the IQR of this. Can we do 25 by 100 into 10 to evaluate the value of Q1? What you are doing, 25 by 100 into 10, like it is 2.5. So what you will do with respect to this quantity? I'm not getting your point. This is wrong. This is wrong. This is wrong. This interpretation is wrong. Simple. If let's say you will be having the data points available and you have to evaluate 50 percentile, you will take the median of that. How can we take a median of a odd value and even value? You know pretty well. If let's say here, instead of 10 data points, we have 11 data points. Let me try to copy this. And let's assume that I'm taking one more data point over here, which is, let's say, I'm taking as 102. By the way, we are not doing a sorting over here because it is already done. That is the main reason. Okay? Now, in this specific case, if I'll ask you, number of data points will become 11. If I'll ask you, what is the value of Q2? What is the value of Q2? What will be your answer? What will be the value of Q2? What will be your answer? You have to directly fetch the middle value because now it is an odd value. So 90 will be your answer. If I'll ask you now, what is the value of Q1 and what is the value of Q3? So what will be your answer? Tell me. We have 11 data items. Now in this specific use case, tell me what will be your answer in terms of getting a value of Q1 and Q2, Q1 and Q3. Take your time and give me the answer. So, Mayank said that Q1 is 77.5. Okay. And what is the answer for Q3? Which particular split you will do? That is my question. You only told me that Priya 90 is the median that we have, right? So this is something which you are saying is a portion of 50 percentile. Prior to that, we have a value which is 56, 64, 75, 80, and 83. Now we have 1, 2, 3, 4, 5 entities. You have to take a median of that. So what is the median of that? It is 75, isn't it? If I'll take the extreme right end values, what is those values? We have 92, 95, 98, 100, 102. If I'll ask you, what is the median of this? You will say 98. It is the value of Q3. This is how basically the evaluation will happen when we have a odd value versus when we have an even value. Now ask me the question if you have. Now ask me the question if you have. Is it clear to everyone? Shall we move ahead? So when we're trying to evaluate the value of IQR, what we're supposed to do is we need to fetch the difference between these two, which is 95 minus 75. In this case, we will be able to get the answer as 20, right? Whereas if I'll talk about the below case where we are having this specific quantity, the IQR value will become 98 minus 75. So how much is the value we will be able to achieve? I think 23, right? So this is what we will be able to get as the result. Check it out and tell me if you have any doubts. Is that part is fine with everyone? How basically we will be able to evaluate the IQR? Now let's try to understand the interpretation of IQR if it is clear. If let's say I'm getting a value of 20, if let's say I'm getting a value of 20, what this value is indicating? First good thing about this IQR is that it is not as such influenced by the extreme ends or extreme values, which was the case with the range factor, which was the case with the range parameter that we have discussed. So IQR is not impacted or influenced by the extreme values. That is why you will be able to observe it is a robust measure of outlier. It is a robust measure of outlier. So always remember, whenever in your data you have an idea, you have an intuition that outlier might be available. So never ever go with the range as a measure of dispersion. Always and always prefer to go with the IQR. Now the last thing with respect to this topic is that many people gets confused regarding the interpretation, which is very important to understand. So I'm writing this sentence, I'm copying over here. Now read this very carefully. When we are getting the answer as 20 as an IQR, what does that indicate? The IQR of 20 means that the middle to 50% of test scores are within 20 points of each other, right? Because if you will be able to see, IQR is nothing but the difference between Q3 minus Q1. 50% of test scores are within 20 points of each other, giving you a better understanding of the student's typical performance without being influenced by the extreme ends, extreme scores. So, a key takeaway with respect to this point, which I want to convey over here is key takeaway is always make sure that range usually provides a quick sense of the variability, quick sense of the variability. But as we have discussed, there is a limitation with respect to this measure. Why? But you can say, but it is sensitive to outliers. It is sensitive to outliers. And that is where we have another interesting measure which we called as IQR. IQR is another measure which offers a robust measure of dispersion, dispersion, which is majorly ideal specifically for those data sets, which contains outliers, which contains outliers. So this is the key takeaway with respect to this example that I want to give, right? इसका मतलब क्या है? इसका मतलब ये है, 20 का मतलब ये है कि आपके पास लेट्स से डेटा पॉइंट है, ये आपका हो गया 50 परसेंटाइल, राइट? ये आपका हो गया 50 परसेंटाइल ऑफ टेस्ट स्कोर. जो IQR है, हम ये बोल रहे हैं 20 वैल्यू है. इसका मतलब क्या है कि 20 इस तरफ, 20 इस तरफ इंपैक्टेड है हमारे पास में. यही तो हम बोल रहे हैं Q3 माइनस Q1 इज द वैल्यू ऑफ 20 विच वी आर गेटिंग. तो हम क्या कह रहे हैं? मिडल 50% ऑफ टेस्ट स्कोर्स आर विद इन 20 पॉइंट्स ऑफ ईच अदर, which gives a better understanding of the students' typical behavior, typical performance, without being, we are not focusing on कि extreme end में उसकी minimum और maximum value क्या है. हम बीच की बात कर रहे हैं, अब हम extreme ends की बात नहीं कर रहे, ताकि outliers का impact ही हमें यहाँ पे ना पड़े. That is the major mean. Yes, you can say that whenever outliers are available, we will always preferably go with the IQR, not with the range, because range is impacted or influenced by the extreme ends. It's not focusing on the middle values, whereas IQR complete maths, if you will be able to observe, is focusing on the middle values, focusing about the range of 75 percentile to 25 percentile. So we have this as 25 percentile, this as 75 percentile. ठीक है, समझ में आया? Is it fine for everyone? Shall we move to the next topic? If everything is so far so good, I think we are doing calculations also, so that things will be pretty much clear to everyone. चलें आगे? Shall we proceed? Okay. The next very important measure of dispersion is what we have in our today's discussion is variance and standard deviation. So third thing we will discuss is today variance. Now, whenever we are talking about variance, the in a layman term, if you will see, it's a data in which you are trying to see the difference from the mean, from the average, right? So it basically tells you the overall spread of the data set with respect to the mean values that you are getting. Always remember why I'm saying with respect to the mean values. You will be easily able to observe this with the help of the formula itself. So it will be sigma square. You will be able to see, you will write I is equals to 1 to capital N, the value of x of I minus mu whole square divided by capital N. So this is how basically you will be able to evaluate the population variance. Now, in the last discussion, we already have seen that what is the difference between population versus sample. Sample is a subset of this population. So let's say you have taken a sample of size small n, which is very, very less as comparable to the value of capital N. And if you want to evaluate the sample variance, which is indicated by S square in mathematical terms, you will say the formula will become I is equals to 1 to small n. You will try to find out the value of xi minus x bar. So always remember, mu indicates in statistical terms, population mean. So wherever you will see in the standard books, always remember mu is the population mean. And if they're using X bar, this indicates the sample mean. In both the means, we're trying to evaluate the average. It's just that the number of data points that we have in a sample is quite less as comparable to the population mean. Upon divided by, in a sample variance, we do n minus 1. In sample variance, we try to do n minus 1. So this is the way to evaluate something called as sample variance, and this is the way, so this is something which we call as sample variance. So in usually in interviews, they can ask from you that what is this variance parameter all about, what it is doing. So the simple answer is that it is basically telling us the overall spread of the data with respect to the mean part. Why we are saying? Because we are doing a difference with respect to the mean value. All the data points that we have with respect to the mean value, we are trying to fetch the difference and doing the cumulative addition of that. So this is how basically we are evaluating the term. We will come to that point, why not n and why n minus 1. But is that formula is fine with everyone? Shall we try to do this with the help of a formula, with the help of one numerical example to understand that how the evaluation is being done? And then we will discuss the further point that why in the denominator we have this n minus 1, again very important widely asked question, that when you're trying to evaluate the sample variance, the denominator is n minus 1, whereas when you're trying to evaluate a sample mean, this is not how things will work. When you are saying sample mean, mu is nothing but the summation of whatever values you have, xi, I is equals to 1 to capital N divided by n. And when you're trying to calculate the value of x bar, you are saying again I is equals to 1 to small n, x of I divided by small n. So in this case, though, you're not doing n minus 1. So why in sample variance we are doing n minus 1? That's another biggest question which can be asked from you. So we will discuss that in a later on stage. But before that, let's try to have one example for the same so that we will get a better understanding for this part. Now, let's suppose that you're running a small business and you're trying to track the daily sales which is happening over a month. Okay. Now, I'm just copying again one data which is looking like this. So let's assume that this is the data set we have. And in this specific data, this is indicating the sales part happening over a month. And this figure is in, let's assume, dollars. So $100, $150, $200, $150, and so on. So this is the sale value which we will be able to get over this specific part. Now, my question is, first of all, let's try to get the sample mean. So let's assume that it's a sample value. So if I'll ask you what is the sample, not mean, sample variance of this, so how will you evaluate? First of all, obviously you have to evaluate what is the value of x bar. X bar is nothing but is the addition of all of these values. So try to add 100 plus 150 plus 200 plus 150 plus 130 plus 170 plus 160 plus 180 plus 190 plus 170 divided by 10. So this number, whatever you will be able to get, is the value of x bar. Now tell me, what is the value of x bar you're getting? So Prabhutva is saying it is coming out to be 160. So I'm writing that only, 160. So when we are talking about sample variance, because you have observed that we have 10 data items that we have fetched. So what we will do is now, with respect to every data point that we have, we will try to take a difference. So what we will do, we will say 100 minus 160 whole square plus 150 minus 160 whole square, 200 minus 160 whole square, 150 minus 160 whole square, 130 minus 160 whole square, 170 minus 160 whole square, 160 minus 160 whole square, 180 minus. So basically, what you are doing is you're trying to take all the data points that we have and doing a difference between the value, given value, and the mean value that we're getting, 170 minus 160 whole square, divided by, because we're talking about sample variance, we're taking n minus 1, which is 9 over here. So try to evaluate it, this specific part, and give me the answer. What is the answer we're getting? Do this calculation a bit and give me the answer. So basically, you will be able to observe with respect to x bar in every specific case, we are trying to take a difference. And that is the literal meaning of variance, that we are trying to take a spread with respect to the mean value that we will be having, which is 160 in this specific use case. The square sum is 7700. Is that true? Can anyone give me the confirmation? Because as per my calculation, I'm getting something different. Just check it out. As per my calculation, it is 3600 divided by 9, which is 400. Just verify once again. Yes, anyone who can give me the confirmation? Just check it out. This value will become 0. Is anyone verified? Maybe you can use calculator and just verify the values. 150 minus 160, which is 10 whole square, plus here we will be having 30, difference 30 whole square, again 10 whole square, 20 whole square, 30 whole square, and 10 whole square. Do it a bit fast. Everyone is getting different results. At least we should have one common result, no? This will be minus 10 whole square, 100. This will be 30, right? 30 whole square is 900. This will be again 100. This will be 400. This will be 900. This will be again 100. Can you guys check what is the difference? What is the outcome we will be able to get after doing the addition? There is one more data point, which is 100. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I have taken all the parameters, isn't it? 1800, 1900, 2000, 2400. So I'm getting 2500 for now, divided by 9. I'm not sure, you can just verify this thing, this specific calculation. Okay. 100 minus 160 here we have. That's true. Yep. This is wrong, right? 100 minus 160 is 60. So 60 square will be 3600. Yep. Yep. I think now we will get some different answer. Remaining things are correct? Remaining things are correct? Right? So 7700 Mayank is saying is the summation we are getting divided by 9. So what is the outcome? 85.56. Just verify at your end. Okay, still verify the calculations. I think it is correct only. I'm not sure in the documentation my team member has written this specific number 3600, but you can anyhow verify, and this is how basically we can evaluate the sample variance. Now, if let's say I want to evaluate the standard deviation, which is the another key term that we have, right? Uh, there is only a significant difference between variance and standard deviation. Standard deviation. It's just that what we supposed to do is we're supposed to do a square root of whatever term we will be able to get. So S is something which is the S square root. Means what you have to do is whatever number you are getting, I is equals to 1 to n, the difference of the values of xi minus x bar whole square divided by n minus 1, or with respect to the population part, if you have sigma is the annotation, which is the square root of sigma square, which is nothing but summation of I is equals to 1 to capital N xi minus the value of mu whole square divided by capital N. So what is usually happening, whatever result we will be able to get, which is 855.56, if let's say I'll ask you what is the standard deviation for the same, you will take the square root of whatever value you are getting, and you can try to evaluate whatever number you will be able to get over here. Now, this is the major meaning of how we will be able to evaluate the variance or the standard deviation. But if I'll ask you what is the interpretation of this term, so can anyone tell me what is the square root of 85.56? What is the answer we are getting? What is the answer we are getting? Just do the square root of this term and give me the result. So it is 29.24. So let's take it as a round of 29 or maybe 30 because we are talking about sales. So let's take it a upper bound. So what does it indicate? This indicates that a standard deviation of 30 means on an average basis, right? Daily sales means the daily sales deviate by $30 with respect to the mean part. Can I say? So there is a daily sales deviate, we can say deviate from the mean by $30. So this is the simple interpretation of standard deviation. Okay, you have a mean available, and when you are saying that this mean value is something which you have determined, so you are saying that with respect to this mean part, how much deviation you have, this is something which we call as mu minus sigma and mu plus sigma in mathematical terms. So we are saying that it will be fluctuating from this specific mean point on a daily basis, average sales by $30. That is the significance of this specific term which we are discussing over here. So does that part is clear to everyone? What is the significance of standard deviation and the variance? Any doubt till so far? Anyone? Now, whenever we are talking about variance, although both are somehow talking about the spread with respect to the mean, but when we're talking about variance, it is usually hard to interpret. because we have a squared units over there, we have a bigger quantity. That is where we usually see, we always go with the standard deviation, because it is quite easier to interpret. We have a square root term, and as soon as you will do a square root of any of the term, biggest term will become very small. So it is very easier to communicate, and that is why you will see in practical real time projects also people are going for standard deviation in terms of communication part. And even in the statistical plots, you will be able to observe that people are working with, there is something which we will discuss in the upcoming sessions called as empirical rule as well, in a statistical portion, where we are working with a sigma. We will not work with a sigma square. The main reason is that sigma square, which is a variance, is a very bigger quantity, and it's very difficult to visualize, interpret, and communicate it properly to the client. So that is where this term of standard deviation comes into picture, where we can just take a square root of that term to minimize that part, but to show the impact also, that how it is varying with respect to the mean part. So that is where these term of standard deviation comes into picture. But everyone should be clearly aware about the difference between these two, and what is the impact that have with respect to the calculation. So any doubts till so far, the interpretation, whatever I have talked about, is that clear to everyone, so that we can move ahead? If there is any doubt anyone is having, please do ask before we will proceed. Why we do whole square instead? Why can't we use absolute values to convert it to a positive quantity? Any answers, anyone? So what he is asking is that in the formula to evaluate sample variance, or maybe the population variance or the mean value, we are doing a squaring of every term, right? We are taking a difference and taking a squaring of every term. So why is that so? Any reason behind that? And if we will take the absolute value, does that makes also sense? Any guesses? Any guesses, anyone? Um, so I have got few answers. Let me read it out. So Mayank is saying that it helps us to give the impact of large deviations. Partially, I would say makes sense. Since mean is not addressing the outliers, why we are using mean in the standard deviation and variance? Okay, that's a separate question altogether. So let's first of all try to work upon the question which Prabhutva has asked. So Mayank's answer is partially correct by saying that like one of the reason is correct. What he has said is, when you are doing a absolute value, you are not doing a squaring of any term. What will happen is deviation difference will not be that much huge. So whenever you are doing squaring of any term, so there are few reasons behind that. I think that would be the reason, one of the reason why researchers have used this kind of a formula and not going for an absolute difference. That is to emphasize the larger deviations, the larger deviations. That is one of the reason. I think Mayank also said the same thing. So when you will be taking a squaring of any term. So squaring, what it will do, squaring will try to amplify the result whatever you're getting, right? Which helps to understand the bigger deviations more than the smaller ones, so that emphasis will be more. This means that if there is any outlier or any data point which is away from the mean value, it will have a greater impact on the standard deviation. And this answers the question of Prasanna as well, which he has asked, that why we are taking as a part of a mean difference if we are talking about outliers availability and mean impacts a lot. That is why we're not taking an absolute value. So as soon as, if let's say you will be having an outliers and you are taking a difference with respect to the mean value and you're taking a squaring of that, so if there are outliers available, they will be very far. And that is where I was talking about empirical rule, right? It is just saying, this specific rule just saying that I have divided my zone of data points into three categories: mu minus sigma, mu plus sigma, mu minus 2 sigma, mu plus 3 sigma, mu minus 3 sigma, mu plus 3 sigma. So this is mu minus 2 sigma, this is mu plus 2 sigma, this is mu minus 3 sigma, this is mu plus 3 sigma. Now if there is an outlier, and if it will try to take the difference between the mean value and that value, because that's extreme, and we're doing a squaring on top of that, so the impact will be that it will be lying outside this mu minus 3 sigma zone to mu plus 3 sigma zone, where almost 99.7% data already lies. In this specific range of mu minus 2 sigma to mu plus 2 sigma, 95% data lies. In this mu minus sigma to mu plus sigma, 60, I think 65% data lies, if I'm not wrong. 68%, I think, I'm not really sure. Let me just check it out upfront so that no wrong number will be dedicated towards your side. So empirical rule, there is a very famous graph, and yeah, 68, 95, 99.7. So that is where you will be able to see that how the handling of outlier is also done. This is one of the method in stats to check the outliers as well, that if there is any data point which is falling beyond mu minus 3 sigma to mu plus 3 sigma, probability is very very high that it is a part of an outlier. That is why their deviation is quite more, and that is the main reason why we are doing a squaring over that specific formula. Another reason could be that when we are, because this specific standard deviation or variance is quite frequently used in so many mathematical derivations, and when we are taking a differentiation or doing any calculus on top of this, so it is specifically doing a squaring will always be mathematically or computationally, I would say, convenient task, or computationally convenient task. That is the another reason, I would say, why researchers have opted for the squaring term as comparable to going with the absolute value. Absolute value will always give the weird results when we will do any of the mathematics on top of that. But as soon as you will apply squaring on top of this, now whatever calculation you will do, it will be very smooth in terms of calculus part. Now let me read the question. Didn't get got it clearly. Can you give an example to showcase it? I think I have already given it. Yeah, please ask me the doubts if you have. Let me just open up chat window quite bit more. And let me just give you the access to speak up as well. Yes, please go ahead.
Can I say, please?
Yes, go ahead, Mayur. Go ahead.
Yes, this deviation, standard deviation, and all the other terms are there. So, like these are some terms actually. I'm finding a little bit difficult. So, uh, is there any documentation that at first I will have to know the exact these things like variance, variabilities, deviations, and also these things so that I can get the knowledge. I'm finding a little bit difficult to proceed.
There is no as such documentations which I have. What I can say is that firstly try to refer these live sessions, the notes which I will be sharing with you. uh, if you find any difficulty, most welcome, you can ask the question 10 times, I'll repeat it again. And after that, maybe you can refer the open source platforms, maybe chat gpt, google chrome, anything like that. Apart from this, I will definitely upload one centered book also in your dashboard very soon. I'm doing few more researches. I didn't get the time. I just need some more time to get that part done, and then maybe I'll upload one book also for you guys referencing, which you can refer in your study. There are 2 3 books which I have downloaded as an ebook, but I will first of all do my own research a bit. Just I'm checking the languages, whichever I'll feel is quite easy language. I will try to upload that book also in your dashboard. So if you want to check with respect to the book part also, you can check it out.
So,
Like
what is the name of the
here,
book?
the deviation and this $30 deviate. The $30 deviate means exactly what it is meaning that I am finding difficult to understand.
If you will be able to observe the way we are trying to evaluate the answer, we are doing a difference between the data point and the value of x bar. X bar is the mean value. In the population, we are doing a difference with respect to the mu, which is the mean value. So difference, what is the meaning of difference? Difference is the deviation only, right? We are doing a difference and then doing the addition of all of these terms. So in other words, this specific quantity $30 is indicating that if, let's say, you have this kind of a distribution in your data, and this is the mean value that you have, which is mu, or in sample case it is x bar. So you are saying that, this value and this value, which is going towards plus 30 or minus 30, this is how my sales is deviating. For example, let's say on daily basis, I'm assuming again, might be the mean value we are getting is maybe 90 dollars. We are saying that on daily basis, uh a businessman is making a sale of $90, but at max he is having a sale which is 90 plus 30. 90 plus 30 is $120, and minimum revenue or minimum sale which he's doing is 90 minus 30, which is $60. That is the meaning. Means the range of his sales is from 60 to 120. Obviously, it will not be fixed, right? This is average, but the fluctuation is going from 60 to 120. That's the meaning of deviation. Deviate. Daily sales deviate from the mean by $30. So it can go to the minus 30 also and plus 30 also. So that is the meaning. That is the
That,
intuition behind standard deviation.
so means 30 will be constant in this specific case, isn't it? After that, fluctuation will happen based on that. Is it?
Sorry, what you're saying?
I mean, as it is deviate 30, it means either 30 will be constant, and after that, extra will be added either in the right side or the left side. But 30 will be there.
30 is not constant. Mean
It's
is
in
constant.
the range.
It's the range. 30 is minus 30. So this is what I am calling it as, in the previous empirical formula, x bar minus s, in this case x bar plus s. Means this x bar is fixed, average is fixed. Maybe you're taking an average of week or average of month, which you're getting this number. This is fixed. But you are saying that on daily basis, how the fluctuation is happening, what is the minimum range, what is the maximum range, that is from 60 to 120. How basically we can evaluate that with the help of this standard deviation term. This is the meaning. Yes, ask me the question if you have.
Ma'am, can you hear me?
Just wait.
Ma'am,
Mayur, is it clear?
I have to study again.
Ask me
So,
the doubt if you have. Yeah. Yes, Mayam, go ahead.
you can think like that. If you are running a shop, you are getting the mean as $90 per day, and you want to see that what is the range of revenue that you are getting each day. So it would be in the range of 60 to $120 each day. It would be in between these two values, and it would be 68% of the revenue would be in the range of 60 to $120 because it is in the range of two standard deviations from the mean, from the left and right side. I think of like that.
Yes. Like you can assume that you are running any kind of a business, and in that specific business, If I'll ask you, Mayur, hey, can you tell me what is your average uh, revenue which you're generating? You will say that, Priya, it is on an average $90. I'll say, okay, it's nice. But what is the minimum which you can generate on a daily basis, and what is the maximum? You will say that, Priya, someday I can, like, minimum I can go till $60. Like, if let's say there will be less customers coming up, but minimum at least $60 I will be able to generate. And maximum, sometimes when it's a good time, people are coming up at my shop to get the, let's say, whatever you're selling, groceries done. So in that case, maximum it is going for $120. So this is how basically this standard deviation plays an important role. So with respect to the mean or the average value, how much is the fluctuation you are happening? Whenever we are working in any of the business problem, any of the use cases, for example, let's say I'm running my own platform, right? Tech for All with Priya. On a monthly basis, I have to check that in a month how much revenue I will be able to generate. So there will be some average, right? There will be average of a month. Key, for example, let's assume that I am saying, Mayur, on an average, after every month, I have launched this platform in January, and let's assume ki on an average, I am getting 50,000 as a revenue per month. This is my, in a way, salary, 50,000. But you will say, Priya, 50,000, okay, but are you getting on a daily basis the lead? On a daily basis, people are purchasing your course. What is the minimum? Like, on a daily basis, minimum this much sale is happening, and maximum this much sale is happening. I'm talking about average, but what is the minimum and maximum on that complete month? So that I will be able to evaluate by seeing my standard deviation, where I'll say that, okay, Mayur, minimum my, let's say, complete Excel course was having a price of 1499. It is being sold minimum on a daily basis, and maximum it can go to, let's say, ML course, which is 6999. So this is the range, right? So this is how basically you have to think. What is the minima and maxima and average? That the three things I'm talking about over here. And that is where the empirical formula is being designed. Ki whatever we are assuming that mu minus sigma to mu plus sigma, where mu is the population mean, sigma is the population standard deviation. Almost whatever be the use cases we are working with, 68% of data will lie under this specific fact, from mu minus sigma to mu plus sigma. As soon as you will move ahead from mu minus 2 sigma to mu plus 2 sigma, almost your 95% of data resides over there. And as soon as you will move ahead to mu minus 3 sigma to mu plus 3 sigma, almost 99.7% data lies ahead. Again, these things are experimentally being proven by the researchers, and any data which falls beyond that, probability of having that outlier is quite heavier. That is why this is one of the very widely used technique in the industries to check that whether the outliers are available in our given data set or not. That's the main idea. Okay, yes, Prabhutva, please ask your question.
Yeah, my question is that, for example, there's a point which is 2 units away from the mean value, and there's a second point which is, for example, is 10 or 15 units away from the mean value. So, ma'am, we can clearly see if just minus it from the mean value positions and take the absolute error. So we can clearly emphasize that there's a larger deviation as correspond of the second point as corresponding to first point. So, ma'am, what is the exact reason to do the squaring? Because we are, just making the computational task much more heavier for the CPU. So, what is the
No,
exact
no,
reason?
you are thinking it very much wrongly. It is not making computationally heavier for the CPU. It is making very very easier for the CPU. That is what I am trying to convey. When you are saying units, you have to provide what is the way with the which you are judging these things. Internally, in mathematical terms, this is judging as per the standard deviation, this value of sigma. When you are saying something is 2 units away, something is 15 units away, in which specific sense you are saying, you have to convey it with respect to mean part, with respect to the mu part. And that is where this sigma term came into picture, to check that value, that unit value which you're talking about. Now, why this squaring is being done and why we are not taking that absolute difference? The main reason is, if let's say we will be having an outlier. Let's assume we will be having some extreme value. For example, my mean is, let's assume, uh, in the above part we have evaluated, right? 23.5, let's say, or 27.5. And my value of sigma, which I am getting, is, let's assume, not sigma, sorry. Yeah, mu is 27.5, and my xi value is, let's say, an outlier, which is 1 CR salary. Now, what will happen when you will take a absolute value of xi minus mu? Here, this is LPA, right? The difference will be quite lower as comparable to when you take xi minus mu whole square. This whole square will amplify the deviation. What is the meaning of amplify? It will significantly increase that outlier value, right? It will significantly increase that outlier value, which makes it bit outside that region. And that will basically help my data to understand that these are the portions which are not under the range of 99.7 percentile value. And that is where you have to stop and either remove them or handle them in an appropriate manner. So basically, and second thing, regarding the mathematical part, internally we directly don't use this term of xi minus mu absolute difference. We usually try to work upon several algorithms. For example, if you remember, in the machine learning part, we have discussed about optimizers, we have discussed about gradient descent, we have discussed about so many things where the differentiation integration works into comes into picture. And these terms are very widely used in the domain of data science, where we are applying the optimizers, we are using the mathematical calculus over that. And when you have an absolute difference, that will make it bit tougher as comparable to doing a squaring. Because if I'll ask you what is the differentiation of x square, it is quite easy to understand, because we know that we can take the square value term back and we can do the power with -1, and that will make a significant difference, rather than having the absolute value, which makes it bit clumsy and complex in terms of looking at the bigger picture. So mathematically also it is convenient, and with respect to outliers also, it is making a more impact as comparable to taking the absolute values. That's the main reason.
So
Ma'am,
I would like to add something here, that
Yes,
if
please
you will
add.
see the graph of absolute, basically the modulus graph, mod graph, it will be in the V-shaped graph. And basically at a particular point of the V, when the two lines are merging at the V point, we can't calculate it is non-differentiable basically. We can't calculate the differentiation at that point because there are two slope in that particular point. So
Correct.
that's the main reason that we are using square rather than the modulus absolute value.
मैम जैसे कि फॉर एग्जांपल जैसे कि मान लीजिए यही वाला एग्जांपल लीजिए या फिर कोई और एग्जांपल ले लीजिए जैसे 1 2 3 4 5 6 और एक आउटलायर आ गया जो कि है 1 CR। तो मैम मेरा यही सवाल है कि जब हम लोग इसको अगर माइनस भी करेंगे तब भी एक काफ़ी एक सिग्निफिकेंट लार्ज वैल्यू हम लोग को ऐसी मिल रही है। हम लोग को पता चल जा रहा है कि ये आउटलायर और एक लार्ज वैल्यू हम लोग को मिल जा रही है। तो मैम मेरा यही सवाल है कि क्यों हमको एम्फसाइज़ करने की ज़्यादा ज़रूरत पड़ी है? क्यों हमें स्क्वायर करके उसको और एम्फसाइज़ करवाना है कि हाँ भाई आउटलायर है? क्योंकि इटसेल्फ अगर सिर्फ और सिर्फ हम लोग मीन एब्सोल्यूट एरर भी अगर निकाल रहे हैं कि एक सिर्फ और सिर्फ उसका बस माइनस भी कर रहे हैं डिस्टेंस तब भी एक काफ़ी ज़्यादा बड़ा नंबर मिल जा रहा है। तो
So,
एक
have you seen a parameter of MAE versus MSE in the machine learning term?
मीन एब्सोल्यूट एरर एंड मीन स्क्वायर्ड एरर। यस मैम।
Exactly. जब हमारे पास आउटलायर्स अवेलेबल होते हैं, तो विच पैरामीटर वी यूजुअली यूज, MSE और MAE?
आई थिंक इट वाज मीन स्क्वायर्ड एरर इफ आई एम नॉट रॉन्ग।
What is the reason behind that?
दैट टाइम आल्सो आई डोंट रिमेंबर
We have to use MAE at,
Correct.
because it
So
is
when
least
out
sensitive to outliers.
Exactly. So just try to work upon a bit about the outliers thing. It's not something which you are talking about. There is a significant difference, but if you will compare that difference with the squared value, obviously squared value will be a bit higher, And when we're working with a huge amount of data, we want to see the differences in a very clear picture manner. It's not that when we're taking a simple normal difference, the impact won't be that much when you're talking about a very huge amount of data. You're talking about 1 2 3 number and 1 cr and comparing with that. Obviously in that case difference will be, in this case, significantly higher. But in practical real time use cases, it's not 1 2 3 versus 1 cr. It can be 50 lakh 60 lakh 70 lakh versus 1 cr can be the outlier in that case. So when we're making a difference between that two, normal difference won't be that much significant, but as soon as you will start doing a squaring of that, it will make a lot of difference. By saying that, it's not that you cannot use the term of absolute. Maybe practically you can try to implement it. Both the things have in our picture. But yes, in practical real time use cases, you will always observe that people are preferring square, and whatever reason I have talked about is the reasons of that. Apart from this, there are few statistical analysis that we will be having. For example, in upcoming sessions, we will talk about ANOVA test, chi-square test. In that case also, as soon as I'll discuss that topic, you will get to know that why this squaring is important. I'll not touch upon those points, but there are, apart from these reasons, also multiple reasons because of which we are doing the squaring of this specific term to make a sense of more better things. Okay.
Okay, ma'am.
Um, okay. Okay. Now, what we will do is, I think I have taken all of your questions. So, whatever part or portion we have covered up, we will try to implement it practically, and then maybe we will try to wrap up the session. So, what I will do is, I will try to open a Google Colab over here. Okay. And if you want to do with me, you can do it. Otherwise, you can try to do this at your end, at your home, right? So let's open one collab file, and in the meanwhile, I'll try to fetch some data also. Mhm. Okay, let me try to download one data. So I'm taking one file. The name of that file is engineering data and descriptive stats. And what I will do is I will try to upload that specific file. Day 2. Okay. So let's upload this and let's try to see how this data looks like. Now, to start upfront, I am expecting few things from everyone. Here, you should be having already awareness of NumPy, Pandas, Seaborn, and Matplotlib framework. If there is anyone who is saying that Priya, I'm not aware about these frameworks at all, I'm not expecting the advanced level knowledge over here. I will give you a few references from where you can start learning about this. Let me just share with you a few videos. I think in the ML course also I have shared the similar thing. But anyhow, let me just share with this again. And even I'll try to share in the dashboard as well. So in my channel part, if you will go and check out the Python programming playlist, where is it? Where is it? Where is it? Yeah, this one. In this specific playlist, you will be able to observe I have covered up pandas, not this one. Yeah, mastering the power of pandas, mastering the power of Python, NumPy, sorry, Seaborn. At least these three videos I'm talking about. Please, if anyone is not aware about these videos, try to work upon it at your end. I'll directly try to load it here, these frameworks, and use it because my focus is mainly on the statistical part. not on the Python frameworks that we will be having, but definitely to implement that, Python programming is the must, which everyone should be aware of. And if you don't have any idea about Python itself, so definitely you have to refer the complete playlist end to end altogether. But anyhow, what we're supposed to do for now is we will try to import pandas as PD, because we want to import the complete dataset altogether. Afterwards, we will try to import the NumPy as NP, and for now, I think these two frameworks are fine. Now, what we will do, data is equals to pd dot read underscore csv, and here I'll try to copy the path of the data that we will be having. So this is how my data looks like. So if I'll try to showcase you the first topmost 5 records available in my data, so you will be easily able to observe that this data contains process ID, temperature, pressure, and the flow rate. Now if I'll try to ask from you, if you will be able to remember, in the very first part we have discussed today the measures of dispersion, in which we have talked about range. Range is something where we have seen that it is nothing but what is the maximum value minus what is the minimum value. So if I'll ask you what is the range of a temperature, what is the range of a temperature, so how will you define that? Simply you will take one variable which is temperature underscore range, and simply what you will do, you will say data of whatever be the variable I'm talking about. For example, in this case I'm talking about temperature. You will take dot max, so it will provide you the maximum value, minus you will say again data of temperature dot min. And as soon as you will try to see this and print the values, so temperature underscore range, you will be able to get the results. So if I'll run this, you will be easily able to see how much is the range value you will be able to have with respect to this part. I hope it is quite easy. Shall we move to the next part, where we have talked about the IQR, if you remember? So if I have to implement the second important measure, which is IQR, which we called as interquartile range, uh, interquartile range. So in that case, you can take the value as Q3 minus Q1. Now, how can we evaluate that? So basically, we need to check what is the 25 percentile value, what is the 75 percentile value. So again, in statistical part, we have a function called as dot quantile, which we usually use. So if let's say you want to see what is the, with respect to temperature, the value of IQR again, so you will say data of temperature, and inside that you will say dot quantile, and inside that you will mention that number 0.25. Similarly, you will try to evaluate the value of Q3, which is again data of temperature dot quantile, and here you can clearly mention what kind of percentile you want. So automatically, whatever calculation we have done, right, to evaluate the 25 percentile and 75 percentile, it will do the same thing internally. And if let's say you want to see what is the temperature underscore IQR, so now you can easily able to evaluate that with the difference of Q3 minus Q1. And definitely you can try to print that value, which is temperature underscore IQR. So if I'll just showcase you how it looks like, this is how you will be able to get the IQR value. Does that make sense for everyone? Shall we move to the next point, which we have covered up? So the next measure which we have covered up is variance and standard deviation. Yes, Mayu, do you have any question?
Not that. No, sir. A quantile function is that one, no, that whatever we discussed in the above, that
Correct.
we are finding a median. That thing is
Yes.
internally doing by the quantile function directly.
Correct. So when you're saying 25 percentile, automatically it will take 50 left, 25 one, and 50 right, 75 one. So this quantile function is doing the same task, which mathematically we have discussed how will it works. Okay. So now the next important function, so next parameter that we have covered up today is the variance and standard deviation. So first of all, let's work with the variance. So just now you have seen In the variance specific part, it will be a square of that difference between the xi minus mu whole square divided by the value of capital N, doing the complete square of that term. So if let's say you want to evaluate with respect to the pressure, what is the variance of the pressure that we will be having? So how can you evaluate that? You will say pressure underscore variance. So you will take that term, that particular variable, variance dot, and now there is in mathematical statistical terms, we have again a function of var, which you can use it. And if I'll try to print now the specific variable, which is pressure underscore variance, I will be able to use it. Oh, not variance, sorry. The column name is pressure, not variance. I'm so sorry. So here, this is the column that we have. So as soon as we will run this, we will be able to get the variance of that quantity. Now, if I want the standard deviation of that, you know the internally difference is just, it will do the square root of that. So instead of doing a manual square root, if you want, you can do it, but we have a function again available. So I'm just copying this part. So instead of getting a variance, let's say I want standard deviation. So you will call this function std and you can print the value. But internally, you can just, because now you know the maths behind variance and standard deviation, you can verify the results and check that whether it's a square root or not. This is the answer which we will be able to achieve over here. So far, so good. Any doubts over here? Any doubts over here? Anyone? Can I get the confirmation? Apart from this, if you will be able to observe, okay, so this is nothing but we can say is the standard deviation. We have this, so all these things we have talked about the measures of dispersion today. Apart from this, in the starting of the session, we have also talked about something called as measures of central tendency, if you remember, right? So if let's say you want to evaluate with respect to any specific parameter, the, for example, average flow rate. Now, let's say you want to evaluate what is the average flow rate. So what you will do is you will directly try to fetch the data with respect to, let's say, flow underscore rate that we will be having dot. As soon as you want to use this function mean and you will print that, it will try to provide you the average flow rate for the same. So let's try to see this. Similarly, you can try using the median over here. I think with respect to this data, I don't think that median will make a lot of sense, but still let's try to do that. So we have another function called as median, and here we can just simply go for it with respect to median flow rate, and we can simply print that, right? So as soon as you will click on this, you will be able to get the median value as well. Mode also, if you want to evaluate, you can evaluate that by using that mode function. But basically, this is how implementation will be done. So one thing you must have observed that understanding is something which requires too much time. If we have a good understanding about internals, that what is the literal intuition behind mean, median, mode, numerically, how can we evaluate range, IQR, quantiles, whatever we have talked about, variance, standard deviation, what are the interpretations of them, at what point of time, which particular parameter is quite measurable. All of these things are quite significant to understand. After that, in Python, it's so easy to implement everything because we already have functions available. We just have to have an idea and knowledge of these functions, and we can directly use those functions to get our task done. Is it fine? So far, so good. Any doubts over implementation part with respect to whatever things we have covered up? I have showcased the implementation as well.
All of these things, whatever standard deviation, quantile, mean mode, everything is individual inbuilt functions are there. So in our case also, we don't have to do anything like scratch, directly use the function, isn't it?
Yes, correct, correct. In your work also, you will not ever apply a manual thing over there, you directly use these functions which I'm talking about here. So
But
you
the
should have a
understanding is
understanding of these functions. Haha, Mayank?
but the understanding is the most important. Where to use which one?
Yes. For example, whatever points we have discussed today, right? Outliers with respect to that, many people like when you're going for an interview, they won't ask you in terms of implementation, can you implement variance? They will ask you the internal things. They will try to confuse you over there. They will say that why we are not using range, or if let's say you're talking about your projects, so they will ask you this question that why you're not using range as a measure of dispersion, why you're going for an IQR, why it's a common method which is very widely used. So you should have a proper solid answer for the same, and to get other person satisfied, you should have examples available. You should have the interpretation of every specific result whatever you are trying to get. It's not that you know the formula, you're getting the answer, but you don't know what actually internally that particular answer is doing. That is something which makes a difference between you versus the other guy who is sitting for an interview, right?
So
uh
like
yeah.
just the last like if there's a code part,
Okay.
please show the code part.
Hmm.
So if this is the first one, whatever I'm finding the quantile,
Hmm.
0.25. So that is the I am doing the Q1. So that is a 25th percentile. So like if the interviewer say that you explain me the Q1 is equal to what, so I will be able to draw it and properly explain what the Q1 line is doing, isn't it? That the internals
Correct.
exactly I have
Correct.
to show that. And the same thing happens for
Yes,
Q9 and the,
you can take a sample data just like the way I have taken to explain you guys, and then you can explain to him that how basically we can evaluate. For example, I think in the above part, right, I have explained everything, how the evaluation is being done in terms of percentile. So that is something similar kind of a thing you have to explain to him by taking few test cases. This example, right? 86.5 is Q2, how we can evaluate that, Q1, how we are evaluating this. So same thing, you can say that it is same thing is happening over this specific big data as well.
and our
Okay.
samples will never contain negative, isn't it? Or I'm wrong.
Sorry, your
Our samples will never contain negative numbers, isn't it? Or it might be.
what kind of samples you are saying?
I am the integer range that whatever we are taking today, it will never contain negative. I'm just asking in
This
scenario.
IQR you are saying can
No, no,
never
no,
be
no, no, not
negative?
no, not that thing. The sample, whatever uh, sample we will be using, that will never contain any negative or like.
It can contain, it depends on the data set,
Okay.
right? It depends on what kind of data they are using. So we are not generalizing anything. It might be the case that if the data contains negative values, it contains negative and it is available and you're getting some negative results as well, right? Okay. Perfect. So now one last question is that when we are trying to evaluate the sample variance, we are getting in the denominator n minus 1, whereas in the population variance, it is capital N. Any guesses why is that so?
Is it because we are giving some kind of bias or freedom?
Yes, correct. So basically, always remember whenever we are trying to evaluate the sample parameters, when I'm saying sample parameters, it means I'm specifically focusing on two parameters. One is x bar, which is nothing but sample mean. Another one is S, which I'm talking about, sample standard deviation. My main focus is that these values will be approximately equal to the population parameter. That's the complete maths. So population parameter is mu and sigma. Mu is the population mean and sigma is the population standard deviation. So whatever work you are doing, at the end of the day, you want or your work is valid, your work is correct. If your value of x bar is approximately equals to mu, and your value of S is approximately equals to sigma. Now, what happens is that when the researchers have tried to evaluate in the same manner which you guys were saying, divide by n, the summation of I is equals to 1 to n xi minus x bar divided by small n. When they applied this formula with respect to the difference between the value of xi minus x bar, squaring of all of the term, divide by n, right? If I'll just remove in this specific formula the value of n minus 1 and we'll just work with n, what they have find out that there is a significant difference between the output that we are getting over here and the output that we are getting with the actual values, which is I is equals to 1 to capital N xi minus mu whole square divided by capital N. So there is this value of S square and sigma square, and if you're working with S and sigma, so there will be a square root in both of the ends. So what they have observed is that there is a significant difference between the value of S and sigma. So they have explored multiple ways to reduce this difference. They have tried with n minus 1, they have tried with n minus 2, they have tried with n minus 3. So multiple ways they have explored that which specific denominator we will put so that the value of S and sigma will be approximately equal to each other, because that's the main target. If that is not achievable, then somehow we are doing something wrong over here. And then they have figured it out in almost all the kind of data points that we're dealing with. If you're putting n minus 1 in the denominator, then the value of S and sigma is approximately equals to each other. This is in mathematical terms called as unbiased parameter. Now my data is unbiased, right? And is giving us a appropriate result in a way that the value of standard deviation is approximately equals to sigma. Why we have not put only n? Because the difference between the range of S and sigma was very, very huge. And that is why they have tried to reduce it a bit by the difference between S and sigma by adding this n minus 1 term in the denominator. So they are introducing this unbiased parameter so that the values will be approximately equivalent to each other. There is a complete research paper also, example demonstration also. You can just refer after this session will get over at your end, doing the research in which they have given several examples and showcase practically that when we're putting n minus 2, when you're putting n minus 3, when you're putting n, when you're putting n minus 1, how the difference will varies and which is the closer one as comparable to the population standard deviation that we have. And what they have figured it out that when we are putting n minus 1 in the denominator, that is where we're getting the closer values. So that's the main reason. So this is the overall idea. I think so far whatever things we have covered up should be clear to everyone. I don't want to add more topics over this, although this descriptive stats is not finished with this session. I think one more session will be required. So we will try to continue our discussion where we will talk about the data distributions in the upcoming class. We will talk about skewness. We will talk about kurtosis. There is another term in statistical term which is significantly very important. And I think in any of the previous sessions of mine, I have never used it. But because it's a dedicated session for statistical part, we will discuss that concept as well, that how it is really helpful in understanding the skewness part in the upcoming class. Then whatever things we will cover up, we will do the implementation for the same. And that is how the upcoming session will go as well. If time permits in the upcoming class, maybe we will start another topic of probability part as well. It all depends on how the flow will go. But I think till so far, whatever topic we have covered up, till day number 2, is it clear to everyone? So far, so good?
Yes, ma'am.
Please try to devote more time on top of this. Although I have tried to share all the practical illustrations, real-time examples, implementation, numerical examples for everything, but your task is not finished yet. Whatever topics we have covered up in today's session, you can try to explore again. Maybe nowadays, so I think, at least for my own learning purpose, whatever things I'm learning new, I'm using ChatGPT platform a lot. So I always recommend to the learners that if you are a learner, you are learning something new, please go and refer that platform. You will be able to get multiple solutions, you will be able to get multiple examples, use cases, everything. You can just ask a effective prompt, effective question from ChatGPT, and it will be able to give you a very great answers. Sometimes it might be a wrong, that wisdom also you should have, but maximum times whatever experience I have seen in my studies part, whatever study and research I am doing currently, it is really helping me a lot. So please go ahead, ask a good questions from Chat GPT, whatever topics we have covered up, whatever thoughts you have, you can just make that platform as your good friend, or maybe your mentor, whatever thing you can find it very effective for you, and try to ask better prompts. It will be able to give you favorable results as well, and get a deeper understanding of whatever things we have covered up. In the upcoming session, we will continue our story with respect to descriptive stats only.